This came as a job lot box of sort of radios I bought a couple of months ago. It was a Roberts Rambler 2, and a little Japanese portable. Well, I think it was Taiwanese. You know, the sort of things you used to get in the 60s and 70s, so like two batteries, single IF or twin stage IF, AM, long wave. You know, the sort of things you used to buy, and the sort of like Tandy used to sell them, the little colourful little radios, little pocket-sized things that you could put under your pillow to listen to Radio Luxembourg, whatever you're into. This was one of the radios that was in with it. When I got to me, it was in a bit of a state. I think you can see sort of slightly sort of worn mark here. It's got no battery covers on the back. It was obviously been, I don't know what happened to it, that someone had obviously sort of taken the battery covers off for some reason, hadn't bothered putting them back on. But it cleaned up okay, but these are notoriously unreliable for their electrolytic capacitors, so I wasn't expecting anything to work. But lo and behold, when I powered the thing up, it actually produced sound, and pretty good sound as well, and particularly on FM it works really very well. But it has got a problem, and the problem is the AM tuning is a mile off. Now, I've come to the conclusion what it is, but let me just show you first of all what it does. I'll tune into Radio 4, and for those in the UK, you know that Radio 4 is on 198 kilohertz. So we press AM 198 execute. There's nothing there, but you can clearly hear the radio is making noise. So there's obviously the receiver's working. It's receiving something. So we tune up and down. Sounds like, unfortunately, there's too much noise in the workshop at the moment. Try to turn that light off. Okay, there's probably too much noise in here at the moment, but okay, so what I'll demonstrate it with the we'll put a generator signal at 198 kilohertz. We'll use the Rohde & Schwarz for that, just so we've got a carrier with some modulation, so you can actually hear something. I'll put in quite a strong signal. So let's try and tune again. There we go. There it is. So we're putting in 198 kilohertz, and the radio is actually tuned in on 180 kilohertz. So the problem initially, you think, is the local oscillators running off frequency. Well, no, that's not actually the problem. This is a double conversion IF system on this, and it looks to me like the first IF is running badly off frequency. Now there is an adjustment for that, and we've tried making the adjustment on the transformer. In the service manual, it actually shows you which adjustment to make, but that hasn't pulled the frequency in. What happens is you can pull it into a degree, and then suddenly loses sensitivity as that oscillator stops working. So what it is let me just show you on the circuit here. Where are we? We've got that. Just had the crystal. Here it is. It's right on the edge of the page. Focus on cue. Focusing there. This crystal here is the first IF oscillator, and this is the transformer adjustment here to try and pull it in. Now you adjust to T11, you can get a small shift in frequency, but you can't get it to the right frequency when 198 actually shows us 198 on the radio. So what we've done is we've gone from one extent to the other, and we basically can't pull it in. So what it looks to me like, this crystal, and this is not an unknown problem with these particular radios. Well, should I say, it's not an unknown problem with these radios, is in they drift off frequency. I've looked on the internet, and a couple of people have said that theirs have drifted off frequency as well. This crystal's not running at the right frequency. Now, I don't know if I can possibly pull it in with some of these capacitors. Unfortunately, they're right on the edge of this page, and it's typical, isn't it? You print the service manual out, and it's right on the edge of the page. It's just basically here on this edge of this page here. Now I've adjusted both these cores, but this capacitor here is basically in a tank circuit for the first IF transformer here, and this other one here, it looks to me that you can't do a lot with them. So that's a second local oscillator, I'm assuming. And go to the other side. Okay, second IF, so it's down here, I think, right on the end of the page. And all the circuits I've got have the same cropped point here, so we can't really see what we're doing. But these are a couple of ceramic capacitors. These won't have changed. We've got a varicap diode here, and varicap diode is basically the I thought that you put a bias on these varicap diodes and it alters the frequency, but this capacitor, it's got a capacitor here. Yeah, that's right. You apply a DC voltage to this varicap, and it alters its basically alters its capacitance. But I can't get this crystal to come into frequency. Now I think this crystal's out of spec. You know, they can drift with age. I know that Shango 066 says that these crystals can go bad and can drift out of spec. It could be this varicap diode, or it could be the programming voltage from the VCO, but I don't think it is. So at the moment, I think I'm going to have to try and find another crystal. I want to try that first. I think that's going to be the most likely problem. I don't want to spend a lot of money on it because these things aren't worth a lot of money. Let's turn off. But the other thing to prove that this oscillator is running off frequency, as you know, if you swamp an IF signal into a radio, you'll hear the IF come through on the radio if you put enough signal in. And I'm going to do that now by turning on the Marconi, which is set to 55.843. I'm going to put the output on. I think you can just about hear that. Let me just alter this frequency slightly. I'm just going to alter this carrier frequency slightly. Let's increase the level, RF level to 1 volt. Oh, our limits anyway, I think. Alter RF frequency because we're not using. I've just remembered because what I'm trying to prove is I'm injecting the signal into the IF so you can hear that the oscillators of frequency, but because I'm at 180 kilohertz, we're not using the whip area, we're using the internal ferrite rod. So let's go to a higher frequency. So we'll go to AM, I don't know, 20 meg. There we go. Okay, so we tuned to 20 meg. Now bear in mind I'm injecting an IF, so whatever tuning I have on here won't make any difference. Let me just show you. It will always come through because the signal's going straight through the front end. It's not being tuned, it's bled through the front end and it's going into the first IF. But you can see that we're actually at 55.84 meg and the IF's coming through cleanly. Now what it should be doing is the IF should be coming through at 55.395. So our oscillator's 55.3 is way off. It's sort of like at least, well, 500 kilohertz off frequency, and that's our problem, and that's why we got such a big frequency shift on this radio. So what I need to do is try and track down maybe a spare board for one of these radios. I've had a quick look on eBay and there doesn't seem to be much around. It's a nice looking radio. I don't know what their performance is like. I don't think they're that great, certainly not as good as ICF 2010, something like that. But anyone out there who's got one of these circuit boards or one of these crystals in their stash, maybe they could get in contact, because I've had a look and I had no luck at all. So it's that crystal there. It's the come on, a bit too close I think to focus. X1 55.395 megahertz. I want to change that. If that doesn't work, I might experiment with these capacitors here just to see if I can get it to pull in. And also check that voltage on the this varicap here. Maybe that would make a difference. But first of all, I want to try that crystal because I'm pretty sure that's the actual problem. Anyway, so this is certainly the first part, obviously, of a video, but maybe more to follow depending on how we get on.